tutorial, I will discuss with you guys about assembly modeling, but in particular, there will be two important mechanical mates discussed. So the first one is the gear mate, and the second one is the screw mate. So the gear mate allows us to allows two gears to interact with each other, and the motion of one of the gears depends on the other one. And then the screw mate, it allows a linear motion to be converted into a rotational motion and vice versa. So a bit about this assembly model. So we have two arms in the top and two arms at the bottom. We have a base and two brackets, one at the top, one at the bottom, and then we have a few pin joints. If you look closely, then you can see that there's a bearing and an adapter here. And then we have a crank, and that's about it. So I'll go on with the assembly. So right now I am in the assembly workbench. I hope you guys know this by now, how to get here. And then I can start with the base as the first part. Make this base a float and then connect these two coordinate systems. Press OK. Now I'll add the bottom bracket. And for the bottom bracket, I would select this face and this edge here, and then make it coincident so that they are, so that basically that this face is somewhat coincident with it, even though it can rotate right now. But when I give the other relation, then the other relation will stop this rotation motion and make this line here coincident. And lastly, if I do is take this face and then put this on, and now it doesn't move. So yeah, so for now our base is done with the bottom bracket. Now we can add in the two bottom arms, this one, and these two bottom arms have a gear. So I'll go and insert, browse, and I'll put the left one here. The right one here. And using constraints, I will constrain them. Press OK, and do the same for the right one. So first this hole with this hole here. It's concentric, but I will change it. Yeah, and then make this face coincident with this face of the bottom bracket. All right, next up is the gear mates. But for gear mates, just one explanation. So for gear mates, these tooth should not merge with each other. They should lie on top of each other. So I have to orient these gears in a way so that these tooth don't merge. So for instance, somewhat like this. Yeah, so this would work. But as I scroll out, I can see that even though the gears lie with each other, but they wouldn't move symmetrically. So this one, so the angle is not appropriate. For instance, when this thing would be vertical, this would have an angle if there was a plane right here. So what I like to do is use mate so that I can orient a part in a way that allows me to do the gear mate much more easily and precisely. So for example, I would do is take this mate and make this and this face parallel so that this arm is vertical, and do the same for this one. And now, as if I see it from here, they are both vertical. And I can delete the mates, but the orientation would remain the same. Alright, so now if I look closely to the gears, now the tooths lie perfectly. And I can use the mates, scroll down, go into mechanical mates, find gears, press OK, and then I can select the gears. So for the gear mates, you need to select, you can select the curved surface, and this surface is also curved. So I would select this curved surface, and the same for this one. And then here I would put 1 to 1, even though it's still 1 to 1 ratio, but for the sake of remembering that it's a 1 to 1 ratio, I would put 1 here. So now if I was to move one of the arms, the other arm would move with it. You see? Let's scroll in and show you guys how the tooth are. So it moves exactly how it would in real life. But the problem in this assembly now is that if I move this arm too low, then this arm would intersect with the base, which we do not want. So I would add in another relation, and this relation would restrict the angular displacement. So if I select this face and this face, scroll down into advanced mates, scroll up, and select this here, angle. And now I can add in a minimum and a maximum angle. So the maximum angle could be, but I need to make a bit of change because I want to orient it first here and then add the mates. Because otherwise it would give the angle in a different quadrant. So again, advanced mates. And here I would put this as 130. And the lowest it can be 40. Press OK. So if I move the arm now, then it would only go up till here, and if I move the arm downwards, it would be restricted to 130 degrees. Alright, so we have our two arms. Now we can add in the top arm, the top left and the top right. So go on Insert Components, Browse, top left, top right, open. So top left here, top right here. Now it can be tricky to make them orient in the right way, so I will try my best. This has to be concentric with this, this has to be concentric with this. Press OK. And then this face has to be coincident with this face here. Press OK. Then I can just move this up like here, and then do the same for the right one. So this has to be concentric with this face. Press OK. Just move it closer. And then this face here has to be coincident with this face. Press OK. And if I move this upwards, you can see that it somewhat has the basic, the main assembly is pretty much done because the gears are the the main part of this assembly. All right, I will now add in the top bracket. Yeah, the top bracket. So sorry, I have to think. And when I think, my speech sometimes doesn't work the same way I would like it to. So this is the top bracket. I would place it here, and then I would do is make this and this face concentric, and then I will delete this because right now it's not oriented the way I want to have. So first I would like to rotate this part somewhat like this. And now take this and this face, concentric, and then make this face and the bottom face and this face of the bottom bracket parallel. Or coincident is much better. Yes, and then lastly I can make the inner face and the outer face of this gear to be concentric. That's okay. Lastly, I would want is to make this face to be concentric with this curved face. And it looks pretty similar to the one at the bottom. So now if I move it, it moves like it should. But also I would like to have a gear made at the top one. It's hard to see, but I will try my best to show you guys what I'm doing. So these are, you can clearly see the tooth here now. I will do mate, scroll down, mechanical mates. Gear, select this, rotate, scroll in, select this, just make 1 to 1 for the sake of, and press OK. Okay. So now if I move it downwards, both the gears move exactly the way we would like it to move. So if I was to hide this, and now if I move this downwards, you can see how the tooth are related to each other. They do not merge, they push each other into a rotational motion. Okay, now I will add in the pins. So insert component, clevis pin, open. And if I go and move around and point at this face here, then automatically it makes this pin go inside of the holes. And I can repeat this process. And lastly, for the last hole, we would place a pin there. Okay. And now we need to add in the locks, the pin locks. So insert component, browse, and then have the split pin. Do the same for the rest. Okay, we have 2 more left, so I'll go on do it as fast as I possibly can. Just to mention that these pins and the pin lock and the pin are not going to be fully defined because they are in reality allowed to rotate. For some reason I didn't select. But it's like too, yeah, I'll just keep it here so that it's not intersecting with each other. Yeah, I'll just move it outside so that they don't intersect. And now next up we will start making this joint. So insert component we would like to have is the bolt and the threaded bolt. So the bolt goes here and the threaded bolt goes here. Very simple, just use this surface and the curved surface of this hole and use mates, make it go concentric, apply OK, use this face here and this face here, apply OK, I'll use this curved surface and this curved surface and make it concentric. And lastly, we want is this curved surface, this curved surface to be concentric. And I think that's about it. Let me just see. Yeah, it's fully defined. It doesn't say so, but what I mean is it cannot move towards the positive z-axis or the negative z-axis. Okay, let's add in the very last part. So we need is an adapter, spindle, and a crank. And one more thing, that is the bearing. Open. I will just start placing. So the adapter would go here somewhere. Spindle is also there. This is at the middle, and then I will place them here. Okay, so what we want is this curved surface to be concentric with this curved surface. Yes, okay. And then we would like to have this curved surface of the adapter, and then use the curved surface of the spindle, and then use this face and this face here. And lastly, we want this face to be parallel to, let's say, this face. We could have also used any other planes, but this would work fine for now. Oh, and lastly, well, it's not last. Still a lot of steps to go. We want this to be concentric firstly, the bearing, and then we want this face to touch this face here. Press OK. Alright, so this curved surface would go into this. That's OK. So it's concentric. So if I was to move this, okay, I will constrain first the spindle, put this right next to the face of the bearing, and now I can just go through. Like there's a problem, so I'm gonna delete the mate that I made for this one, and then I would add it again. So I would first make it come here, then use mates. Sometimes you just need to orient it in a different manner and then try the mates again, just like I did. You might think that SolidWorks would do this, but then it does something completely different. So just be patient with it. So press OK. Yeah, it's fine for now. And then I would like to make is I'm going to add in one of the pins, components, use the split pin, open, and just place it right there. Press OK. Just look at it so that it doesn't coincide with it. So what I would do is just gonna take this face here and make it tangent, not tangent, but I would just make it coincident with it. So yeah, something like that, and then make this curved face tangent to it. Yeah, so let's see if it's fully constrained. Yeah, so it can rotate, but I can stop the rotation, and I want to stop the rotation of this as well. So what I would do is to stop the rotation, I'm gonna use is one of the axes. So I will use view temporary axis. Now there's a lot of axes that showed up, but I will be careful. So I will use this axis to be oriented in the direction of this, not parallel. Yeah, so they're parallel. And lastly is to flip the side. Yep, like that. Press OK. Press OK. Now you can see that there's a problem with this because I used tangent, but it orients it in a very weird way. So I'm gonna delete the tangent, which is this one. And then I would make is push it here. I'm just gonna give, let's say, a distance. So I will give a distance of this with no, that wouldn't work. So what I would do is I would again try to mate it, but first I would do is take this axis here. No, not this one. Yeah. This axis here, and use this axis and make them parallel. Press OK so that it stops rotating. And then I would take is this face here and this face here, not tangent, but rather a distance. And I will just put something like 5.5 just to make it constrained. These mates that I did in the last are not do not determine how this assembly would work. But as I said, the main part of this whole assembly was the screw mate and the gear mates. The gear mates are done, but I would move on to the screw mates. So if I rotate this assembly also moves, but it doesn't move as it should. I'm going to just pull it downwards to its maximum angle and start with the screw mate. So go on to mates, delete this selection, go to screw mates, and for screw mates you need to select two axes. So the axis of the for instance of the spindle, and then the axis of the part that moves along this axis. So we will select this axis here and then try to rotate it and try to find the axis of, well, yeah, it was hidden underneath this main axis, but you can find it. And if I was to change it to 10 millimeters so that it moves much faster, press OK, press OK again. I will hide the axis now and also the coordinate system. And now just use this to rotate, and you can see how the whole assembly moves along with the rotation. That's it. So this is how screw mates and gear mates work. That is how you can design some very complicated machines using these extremely basic mates. And the gears interact, the screw mate interact the way we want, and when we rotate the crank, so does the car jack moves up and down. Thank you guys for joining, and hope you guys watch the next tutorial video. Bye.